Assalamu alaikum everyone. I am Daud and today I'll present my IoT based smart parking system project. The system automates the parking management using IoT technology. In this video, I'll explain the project features, GitHub repository, and show the code finally with the live demonstration of the video. Moving toward the system or project overview. The IoT smart parking system is designed to efficiently manage parking space using the sensor and the real-time web dashboard. The project monitors available parking slots, control entry and the exit gate, and update the system status continuously. Key components used in this project are esp32 microcontroller, IR sensor for the entry and the exit points, servo motors as actuator for the gate control, and the web server. The web server or a web dashboard displays the total parking slots, available slots, occupied slots, and the gate status. This allows user to, or parking attendants to know exactly the status of the parking in the real time. What this project does, it automatically detects the vehicle entry and the exit, control the parking gate without human intervention, display real-time parking lot slots available, provide the live web-based dashboard, store parking data on the cloud for monitoring. What is its real world application? It is it can be installed in the shopping malls, office buildings, educational institutions, and hospitals. So let's dive into the GitHub repository. Here is a repository where I have uploaded the complete project, including the Arduino sketch. Here is the Arduino sketch. Complete code available will here. You can just copy and paste into the Arduino IDE and just burn into the ESP. And uh, comments are all the comments are included in the readmd file, so you can easily implement the whole project. What hardware do we need? ESP32 dev board, IR sensor for the entry and exit points, a servo motor for the gate control, LED lights for the status for opening and the closing of the gate, breadboards, and some jumper wires. The software we will need is Arduino IDE, ESP32 web server, HTML, CSS for the web page, ThinkSpeak cloud platform for IoT based control or monitoring. Working principle will be simple. IR sensor detect vehicle movement and ESP will process the sensor data. Then servo motor control the gate automatically if the parking slots are available. Then parking data will be shown live on the web dashboard. Data is uploaded to the ThinkSpeak for cloud monitoring. So let's dive into the code. At the beginning, we initialize the hardware, ESP microcontroller, IR sensor, and entry and exit points, a servo motor for the gate control, and LED for the status indication. Here is the complete. Firstly, here are the header files, and then we simply mention the pin of the IR entry, IR exit, servo pin, green LED pin, and the red LED pin. Here we simply include our Wi-Fi credentials as our system will be live on the web server. So what will be available on the web server? The web server will show total 4 slots. The available slot will be 4 initially. The entry flag will be 0, that no car is entered in the parking. And the exit flag will also be the 0, as no car exit the parking. And we initialize a variable gate status, that is a string data type, and at the starting of the system it is closed. Then we initialize the gate opening timer. We used millis timing operator, so that our code will run continuously and smoothly without stopping all the code while using the delay function. So our gate opening timer was 2 seconds or 2000 milliseconds. Here is the update LED function code. When the gate will be open, or when gate will be open, or green LED will be turned on if the available slots are greater than 0. If available slots are greater than 0, then our LED will be green LED will be high and red LED will be low. Or else if slots are equal to 0, then green LED will be off and red LED will be high. Void data handle function is it just act as a third party operator between our HTML based server and our ESP code. It just converts the data used in the variable data used in the ESP code and convert it into the JSON file for the web server. Here is the simply our HTML code for the web server. We just embed our HTML code in the ESP32 for the smoother implementation. So just copy and paste if you do not want to change. In void setup, we just assign the pin mode, that is IR entry as the input, IR exit is the input, green LED as the output, and red LED is also as the output. So for the serial communication, we use the baud rate of the 115200. For servo motor, we attach the servo pin and the servo right to 90 degree. 90 degree will be the closed angle for the gate is closed, and the 0 degree will be the if the gate is open. So we initialize the Wi-Fi begin to when the ESP will be turned on, it will be connected to the network. While moving toward the loop function, here is the system. Here system continuously monitor the IR sensor. If the digital IR entry is low or and flag is equal to 0, then it put the flag entry is equal to 1. If the IR entry, so here is the if function, it will be opening the gate if the slots are available. It will check if the available slots are greater than 0. It will change the gate status to open. At starting it was closed, and barrier servo dot write equal to 0. And we know previously that barrier servo dot write 0 is opening the gate, that is changing the servo angle. Whenever the servo is rotated to 0 degree angle, it always start the timer that we previously set to 2000 milliseconds, and available slot will be reduced minus 1, that 4 minus 1 is equal to 3. And it also update the LCD status function that we previously defined, or else it will show full message function. After the car pass the entry gate, it have to close the door again. If digital IR entry is high and flag entry is 1, then set the flag entry is equal to 0 for closing the gate, and also update the LCD function. For exit, we will or second IR sensor will be reading the car in front of it. If digital read IR exit is equal to low, then flag exit is equal to low 0. Then set the flag exit is equal to 1. The car slots are available are less than total slots, then gate status will be opened. It means if the car slots available are 4 and total slots are also 4, then it will be open. If the available cars are 0 and the total car slots are 4, then gate will not be open as there is no car in the parking lot. So the gate will not open at start. So it will again open the gate and again timer will begin. So whenever car exit, it have car available slot will be increased by 1. So again update LCD code. After at the last, the gate will be closed by changing the flag variable. IR exit is equal to high and flag exit will be 1. When it will be detected, then we set flag exit is equal to 0 and update our LCD function.
After the code explanation, moving toward the demo part. Whenever you upload your code into the ESP will show its IP over serial monitor. So as I have previously uploaded my code over ESP, so I have to check my IP from my laptop hotspot, as I have connected my ESP from the laptop hotspot. So I have just copied this IP and opened it into the web browser. So as I have set my available slot variable equal to 4 in the code, so 4 slots are available. At start 0 slots are occupied and the gate status is currently closed. slot number 1, 2, 3 and 4, all slots are available right now. So moving toward the demo part, whenever a car moves from the entry, it will appear in the IR sensor at and the gate is open. So now slot number 1 will be occupied, as latency is a little bit higher, so it will appear a little bit later. So slot number 1 is occupied, and moving again, there's second car, the gate status is opened again, and due to little bit latency it will update it's a little later. So this is all from the demo side. We have connected our ESP with the IR sensor and the servo motor, and on ESP our motor is connected on pin number 25, and IR sensor at input is connected at the pin 18, and IR sensor of the exit is connected at pin 19. As we have connected our wires of 3.3 volt for IR sensor and for input and for IR sensor at exit over the breadboard, and we supply our power for the IR sensor from the ESP, and ESP is powered by my laptop. As we log in our ThinkSpeak account, while you uploading the code, we mentioned our API key over in the code, and then log in our account in the Chrome web page to visualize our web status of parking incoming and outgoing. That is, graph number 1 is showing our available slots over that some time period, and graph 2 is showing occupied slots over some time period, and our third graph, that is gate status over some time period. So let's go for demo. When a car is entered, the gate is open and it go into the parking, and here it will upload the graph. It will, as we see, some values are changed. The whole data of the complete hour will be uploaded in some time. The gates available slots for the 6 to 12 time or 4, and for 12 to 18, that is 6 o'clock, the available slots are changed as we performed some demos and testing. And occupied slots for 12 to 18 were showing these graphs as we performed some testing. And similarly for the gate status, the similarly graph is showing the whenever the gate was opened and the closed.